Welcome back to PV Online. Today we're going to take a look at a couple more example problems. And the first is, you know the object's weight. We have a person weighs 560 newtons, and we want you to find the mass. And we know that the weight, which is the gravitational force, equals mg. And if you weigh 560 newtons, that's going to equal your mass times, now, unless you're told otherwise, assume you're on Earth. So that means the gravity is going to have a value of 9.8. We solve for mass, and that gives us 57.1 kilograms. So the mass of the object would be 57.1 kilograms. The weight on Earth would be 560 newtons. Which one of those values never changes, no matter where you are? And the answer to that would be the mass. So whether you're on the moon or Jupiter or Mars, your mass would still be 57.1. Okay, we push with 30 newtons on a 10 kilogram chair, and there's 20 newtons of force of friction. So the first thing we're going to do is let's do our force diagram. So here's my chair, and I know I'm pushing, and I'm going to say I'm pushing to the right with a force of 30 newtons. And we have friction, which is acting back like so. And friction is 20 newtons. But we also have mg, and we also have the normal. Now, if you look at these forces, remember, isolate what's happening vertically and what's happening horizontally. And vertically, what do you know about these two forces? And we know these two forces are balanced, meaning the normal is going to equal mg. Horizontally, they are not balanced. The force applied does not equal the frictional force, meaning that chair is going to accelerate to the right. And I know it accelerates to the right because 30 newtons is larger than 20 newtons. So we start with Newton's second law. The sum of the forces equals ma. 30 newtons minus 20 newtons equals the mass of this thing, which was 10 kilograms, times a. That gives me an acceleration of 1 meter per second squared. That will be the acceleration of my chair. Here's another example. We have a box, and this box has a mass of 10 kilograms, and it's got a net force of 41 newtons acting on it. We've got tension in the cable. Don't forget mg. Gravity is going to be acting on this. And we know that we have a net force of 41 newtons. That means that after I subtract those two, we have 41 newtons left over, which means the tension has to be 41 newtons larger than the weight of the box. So I'm going to take this and say, you know what? The sum of my forces is going to equal the tension minus mg. Well, I know that the net force is 41 newtons equals the tension minus the mass of this thing, which was 10, times 9.8, that's going to give me a tension then of 139 newtons. Remember, mg is going to be 10 times 9.8, which is 98. There's 41 newtons difference between them. The tension has to be 139. Now, to find the acceleration, I need to go back and use the sum of the forces equals the mass times acceleration, and the net force we said was 40. The mass is still 10. The acceleration of this box is going to be 4.1 meters per second squared. In our final example, we have this bucket, which is initially at rest. So my initial velocity is 0. It's pulled upward by a tension. Now, is that the only force acting on it? And the answer is no, because remember, you've got to remember mg. Now remember, the rope or the tension force always acts away from the object. So we have this constant net force, this constant upward force, and it reaches a final velocity of 12 meters per second in a time of 3 seconds. All right, we're going to have to go back and use our old kinematics equations to find the acceleration. And we know that the final velocity equals the initial velocity plus the acceleration times time. My final velocity is 12. My initial velocity was 0. That means our acceleration of the bucket is 4 meters per second squared, and that's up. So now I want to find the tension in the rope. So I'm going to use the sum of the forces equals the mass times acceleration. That gives me tension minus mg equals ma. Tension minus, what was the mass of this? 10. Whoops, got to write the 4 in there. So when I add the 98 to the right-hand side, that gives me a tension of 138 newtons. All right, when you solve these problems, start with the force diagram and then remember to use the sum of the forces equals ma. Good luck and we'll see you next time.